Okay, so this is a practice problem with the speed of a wave, a transverse wave, along a rope. All right, so our problem reads, a transverse wave travels along a rope of length of 4.8 meters and has a mass of 1.2 kilograms. The wave has a frequency of 55 hertz and a wavelength of 2.4 meters. So the question is, what's the tension in the rope? All right, let's write down kind of those key features that we're interested in knowing. We want to know the tension. And we know that the tension in a transverse wave along a rope is related to the wave's velocity. So the tension and the rope material itself is what gives us the wave velocity. Remember, the velocity of waves is dependent on the medium, and in this case, the rope is our medium. We know for the rope for a transverse wave on a rope, the velocity is equal to the tension divided by the linear density. And remember, in this case, this is linear density. And our linear density is equal to our mass per length. Okay, so our linear density is mass per length. That's the square root. The velocity is the square root of the tension over the linear density. If I want to know the tension, then I can solve this relationship for tension, and I get the velocity squared times the linear density is going to give me the tension. All right, so I know that that linear density, velocity squared, is equal to the mass per length. That's going to give me the tension. So I need to know what the velocity of the wave is. Well, we're given that the frequency of the wave is equal to 0.55 hertz. And we're also told that the wavelength is 2.4 meters. Well, although the wave speed is dependent on the properties of the medium, the relationship between wave speed, frequency, and wavelength is a set relationship. So if we look at our wave equation, we know that the velocity of a wave is equal to the wavelength times the frequency. So I can use that information to get my wave velocity. Our wavelength, again, is 2.4. Our frequency is 0.55. So the velocity of my wave is equal to 1.32 meters per second. I can then use that in my tension equation. So, solving for the tension, we have 1.32 squared. Our mass is given to us as 1.2 kilograms. Our length is given to us as 4.8 meters. This equals our tension, which, if we calculate that out, we get 0.44 newtons. So just about a half a newton of tension in that wave when my wave is traveling at 1.32 meters per second. All right, so using both the wave equation and our understanding of how transverse waves move along a string in terms of the string's properties, the tension and the linear density, using those two ideas together. Good job.